Okay, first thing I want to show you today is how to find the answers on Schoology. So, if you are in Schoology and you click on this course, you got a choice of looking at assignments, and I know a lot of kids just look at assignments and that'll work. Okay, click on assignments, but then you got to kind of know which one to look for. And I mean, was this the one that was that's right, or is it this other page 51 over here? Well, if you want to, you can go instead through the calendar. And if I go over to Schoology on the calendar here, I click on that and I say, okay, if Mr. Server talked about it on Thursday, then it'll be on the calendar when? For Friday, because it's the due date. All right, so then you click on Friday here, and there's less stuff. There's only one thing. There's the homework, and then there's the video. Okay, now I click on this for homework, and the next thing that pops up is a PDF. Now, if you have trouble opening that, it's probably because you don't have the latest version of the PDF reader, and it really isn't that hard to get that, up. You can get that online. It's a download. It's free. Doesn't even take very long to get. Adobe Reader, it's called. All right, so once you're in there, hit open. You're going to see the prerequisites answers here, but if you're looking for page 50, because that's what the book said, you'll never find page 50 in here. You've got to find it by section. All right, so the section that we want for this is not section P1, that's the one you see on the screen there. We want to find section P5. So if I hit Control F, that's the find thing. It keeps me from having to scroll through the whole document. See the little blue thing that opened up here? Now if I want P5, notice they said P.1. Then I'm going to say P.5. And I hit Enter. And it brings me right to it. Look at that. Section P5. Solving equations graphically, numerically, and algebraically. The first questions are exploration questions. That's not what I assigned. Scroll down. The next questions are review questions. That's not what I assigned. Scroll down. And now I finally get to it right here, the P5 exercises. And there's number 1 and etc. And you can see all your answers that you will need for this section. So this is, until we're out of the P section of the book, this is the answers for all of them. So I'm just trying to show you how to use it, because I had a lot of people not understanding, exactly where to find them and how to open them and how to search to the right spots and stuff. So, all right, enough of that. Next thing, 4 ways to solve a quadratic. All right, here is a quadratic. That's a quadratic because it's got a little squared in it. I can solve it in 4 different ways. There's 3 though that you're going to use most. So I'll focus on the 3 ways. You can factor it. Would you please write this one down and factor it right now? All right. If I'm going to factor this, I'd say x. Oop, B, I don't know why my pen isn't working. I'm going to try this. There we go, x plus 1, x plus 1. Did you get the same thing as me? Then you should have had x equals -1 as your answer. And I get another one, which is kind of weird. And the only reason for that is because on the graph, do you remember on the graph that when it touches once like this, that's called a bounce? It's called a double root. There's 2 of the same thing. All right, so there's 2 answers of -1. All right, so that's one way to graph it with, or sorry, one way to do it is with factoring, and I get -1 as my answer. Let's go back and see, what does it really mean to have -1 be the answer? If I stick -1 in this equation, what would happen? It would work. That's the point. If I stick in -1 right here, and I stick in a -1 right here, it'll make the equation true. It'll make it equal 0. That's why we call these things zeros, because they'll make the equation equal 0. The reason we call them x-intercepts is because if I graph it, it's where it touches the x-axis. See, that's the x-intercept. Excuse me. And last way I could do it is by quadratic formula. Well, that's not the last way, but it's the last way people use it a lot. And if I'm going to do the quadratic formula, I need to know it's A, B, and C. What is, in this equation, the A? A is 1. It's the thing in front of that. What's the B? And what's the C? So if I stick in 1 and 2 and 1 into the quadratic formula, I should get the answer of -1. Let's check it and make sure it actually works. Okay? Just, nobody's going to hear you. Just sing it quietly along with me. X equals -b plus or minus, I can't hear you. Root of b squared minus 4ac all over 2a. All right. You really have to have that memorized. X equals, and then what should I put for -b? -2 plus or minus square root of what? 2 squared, which is 4, minus 4ac. I'm going to put parentheses because it's too hard to try to do all that in my head. 4 times a, which was 1, times c, which was 1. All over 2a, and that's 2 times 1, which is 2. And then, I'd like you to finish that off and make sure that it actually equals 1 and -1. It will require a pencil or a pen, not just staring deeply into the board. -2 plus or minus. Wait a minute. What's underneath that root? 0. So it's the square root of 0, so it's just 0. All over 2, and then that's -2 plus 0 and minus 0 are the same thing, aren't they? So I don't even really need the plus minus, do I? All over 2. That's why I only get one answer twice, because you could do it twice, but it'd get the same answer. All right? Okay, so the quadratic formula is a good way. The graphing is a good way, and the factoring is a good way too. All right, now if in your homework today, if you're given the choice, I prefer factoring first. Just a quick look. If you don't see how to factor it easy, if it doesn't come to you pretty quick, then I go to the graph. Graph's probably the second easiest. And if the graph is getting to be like, I can't see the stupid place where it touches, I can't find it, it's getting frustrating, then go to the quadratic formula, because it'll always work. That's the one nice thing about the quadratic formula, is it will always work. It just might have big numbers, but then when you take the square root of them and everything, you get the answer. The quadratic formula is nice because it will always work. All right, so there's the ways to solve a quadratic. Some basic math you need to know. Here is one thing that we haven't talked about enough yet. It's an absolute value equation. All right, would you write that one down, please? Now it splits into 2 parts because absolute values have 2 answers, except in the rare case that they come out to 0, in which case, you can have only one answer. Absolute value of 0 is 0. Done. All right, in this case, it's going to split into 2 parts. 2x minus 1 equals 5, exactly what you see. And then 2x minus 1 equals what? -5. Because we want what's underneath here to either be a 5, because see, that would work. Or we want it to be a -5, because see, that would work. So we're taking what's underneath the blue scribble, and we want to have it be -5 or 5. That's why we write it out like this. Then you add 1 to both sides, and you'd have 2x equals 6, x equals 3. And then over here, you'd add 1 to both sides, and you'd have 2x equals -4, x equals -2. All right, so it's got 2 answers. What do you think would have happened if I would have graphed this side and graphed this side? What would have happened? They would have crossed. Where they crossed would have been the answer. I want you to see that. We already know the answers are 3 and negative 2. I want you to grab your calculator. I want you to type in on the first line, y equals absolute value of 2x minus 1. Now you got to find the absolute value thingy. Does anybody know where to find it? It's under math. Very good. So first go to y equals and get in on the first equation thing, and then as soon as you want to type absolute value, you go to math key. And under math, you just go down a bit and you'll find absolute value. All right. So if I've graphed the two things I circled in green there, basically you're going to have a V-shaped thingy and a line going across, and where they touch, this spot and this spot, those are the key spots. Those are the places, the x value of which, because remember these are x answers I want, the x value is going to be negative 2 and 3. Now, how do you actually, like, I'm going to zoom in on that big graph thing. Someday I'll have graphing software working so I can do this for real. But let's say that this was my graph, and I know I want to get to this spot and this spot, but I don't know how to do it. It's under math. No, it's under second calculate. Once you have this graph on your screen, would you please hit second calculate? If you don't know where that is, just like turn to somebody and ask them, like, where's the calculate button? It's at the top right, kind of. It's right above trace. Second calculate. All right. Now, which of those things do we want to find? Do we want to find the zeros? No, this thing, I don't care where this thing touches the x-axis. I want to know where it touches each other. So what's that called? Intersect. Choose intersect. Now, what's the first question it asks you after you say intersect? First curve. What it's asking you to do is identify the first of your lines that you want to find the intersection of. So you get onto one of these two lines. I don't care if it's this one or this one, but you get onto that line, and then you hit enter. And then what does it say? Second curve. Then you get on the other line that you want to find the intersection of, and then you hit enter. And the last thing is all of a sudden important. In the past, the guess thing, you just kind of like, it doesn't really matter, hit enter. But in this case, you got to tell it which of these two lines, see, they touch two spots. There's either this spot or this spot. Which intersection do we want? And on the guess thing, you get near the one you want, and then you hit enter. Did you get, I think this one was the negative 2 one, right? Can anybody verify it actually was negative 2? All right, good. And then if you go do the other one, you say first curve, get somewhere on this one or this one, doesn't matter. Second curve, get on the other one. And then the guess, you get really close to this, and then you hit enter, and I hope it says 3. Everybody get that to work? All right, if you didn't, please ask me, and I can give you a separate little lesson on how to do that. That's really important. Okay, other little basic math skills that we need to have you recall at this point. Square root of 200, I know you don't just have it memorized, but you should at least know that it can be simplified down, and you could boil this down to square root of 100 times the square root of 2. You remember these kind? And then the square root of 100 is 10, so it's 10 root 2. Raise your hand if you could have done that yourself. Okay, good. Then do it on this one. Square root of 72. Now, I know not all of you are going to get this on the first try, but keep simplifying it until you find it. Now, I don't want the decimal for it. That's not what we're looking for here. I'm looking for simplify this, break this down. Now, I know some of you are going to be going, okay, 9, 8. 9 times 8 is 72, and you're right. And this would be 3 root 8. But then you got to keep going, because that 8 has to be done. And then you'd have to say 3 and then root 4 root 2. And then it would be 3 times the square root of 4 is 2 root 2. So it would be 6 root 2. Raise your hand if you got it to 6 root 2. Did anybody get it there a better way? Yes. I agree. And then you'd have 6 root 2 right off the bat. See? Faster. Either way works, though. Yes, sir. Yes, find the largest perfect square that goes into it. But honestly, instead of farting around for 10 minutes trying to find the biggest one, if you know this one works, then you just do that and know that this one can then be simplified farther. You know what I mean? So instead of trying to think all the factors of 72, just do it this way. And then it just takes a little more time on paper, but sometimes it's faster in the end than racking your brain to try to figure out that it's 36 times 2. Either way, you're going to get the right answer as long as you simplify far enough. All right, good enough on that. Why do you care about that? Because a lot of times they're in this kind of problem. The quadratic formula ones come out like this. So you got to be able to go 3 plus or minus, oh, that's 36 times 2, so that would be 6 root 2, all over 6. You see what I did there? Just replace this with this. But now you have to be able to simplify farther and say, ooh, there's a 3 and a 6 and a 6. They all have something in common. What do they all have in common? A 3. And so 3 goes in here once, 3 goes in here twice, 3 goes in here twice. Final answer, 1 plus or minus 2 root 2 all over 2. And a lot of kids want to cancel that 2, and then I have to hit them over the head. Because you're not allowed to cancel those 2. Because why? Because it has to be in all 3 of them if you're going to make that cancel. Okay? All right. So, try simplifying that one for me. The 6 and the 12 and the 24 all have a 6 in common. Goes in there once, there twice, 4 times, 1 plus or minus 2 root 3 all over 4. And you can leave them like that. What if I had to have the answer as a decimal? Well, then I take my calculator, figure out what the square root of 3 is, and just multiply it out and go 1 plus 2 times the decimal, all divided by 4 equals. So you could do it if you needed the decimal. All right. How about that one? Even simpler. You should be able to go really quick in your head when you see them. A plus 5 over 2. Okay. All right. Now, why are we doing all of that? Because sometimes when you're in the middle of the quadratic formula, you'll end up with those square roots in them. This one, I want you to do the quadratic formula to it real quick. Just right off the top of your head, you should know, oh, it's negative b plus or minus square root. Just keep on going and simplify it all the way. Did you get it? Was the square root of 72? And that's the one we did before in class, so you should have recognized it. 6 root 2, I hope. And then I can cancel stuff. Do I have to put it all over 1? Dividing by 1 doesn't really do anything, does it? Do I have it right now? I think I do. Who's got the same thing as me? Okay, good. All right. So there is just a little reminder about quadratic formula and how to simplify those well. Now the assignments here, and I don't want to just leave you to do it because there's a few tricky ones on here that I want to help you to talk about. So would you please grab your book, open it up to page 50, and we'll do the first couple of these things. I'll help you get started. Page 50, number 45. I'm going to pause while you get there. Okay, so here's number 45. And they give you this big, hairy, nasty equation here. And then they have two graphs. They have one graph that looks like that, kind of, and you got two intersection points. You got one graph that looks kind of like this, and it's also got two intersection points. How could those both be the answer to this question? Because one of them has graphed this side and is seeing where they cross. You get that? And the other one, what's this one here, though? There's only one equation. Yes, they've moved this stuff over to this other side and then graphed it, and you just have to find the x-intercepts of that. All right? So, part A. Read part A with me. The viewing window in A illustrates the intersection method for solving. Identify the two equations that are graphed. Well, they gave you the equations, right? The two equations are this one and this one. Those are the two equations that are graphed. Part B. The viewing window in B illustrates the x-intercept method for solving. Identify the equation that is graphed. So what they're saying is, if you were going to use this, it's because they moved this stuff over to the other side first and set it equal to 0 and then graphed it. And they just had to find the roots, or the zeros. So what they're asking is to take this equation here and move that stuff over to the other side. And one common question I get is, does this stuff go underneath the root when it goes out of the other side? No, it does not. It stays separate. Excuse me. All right, that's enough on that one. Then there's a few others that are fairly easy. We've already talked about how to do. Then we're going to get to 59, and you're going to go, oh, crap, a word problem. And some people's first reaction on word problems like that is to say, word problem, I'm probably not going to figure this out. I'll try reading it once. And then you're like, I don't think I know what to do. So then you skip it. Here's the thing. In this class, we assign in the homework very few word problems. But yet when we give you your test, they will be just like the word problems that you did. If you don't get the word problems right, you can't get an A or a B in this class. Because the way the tests are set up, the easy ones, if you get them right, you get a C. And if you want to get an A or a B, you have to get the word problems right. Okay, so don't skip over the word problems in this class. They're like the most important ones. Because if you really want to get it, you got to fight through them. They take longer, I know, but we got a shorter assignment. And you got to understand how to do those, because those will come back again on the tests. And they're a lot like what you see in the homework. So it's not like we try to make really freaky, weird ones for the test. We just take ones that are just like what you had in your homework. So if you fight through them and you get through them in your homework, then when the test comes along, you'll be like, oh, this is just like that one in the homework. All right, so take the time. It's worth it. All right, so now listen to me, because you're going to have to do a lot of word problems over the next month. And there's certain thing, if you do it a certain way, all the problems are kind of alike. Here's the key. You can always draw a picture. In this one, I have a rectangle, so I'm going to draw a rectangle. So please, everybody, draw a rectangle. Even if you think too smart to draw a rectangle, trust me, when you get to the harder problems later, you have to have a picture. So draw me a rectangle. Some of your papers, I don't see a rectangle yet. Make a rectangle. Okay. On your rectangle, we have two sides, length and width. I'd call them L and W. In a second, as we know more information, we will add more to that. Then, in fact, I think I'm ready for that part. So would somebody please read me that problem? Would you read that problem for me? Thank you.
Several of the World Cup men's soccer matches were played at Stanford University's stadium at Menlo Park, California. The field is 30 yards longer than it is wide.
Stop. That was the key statement. Obviously, all the other stuff was just background about soccer playing and all that. So the field is, would you read the part again?
The field is 30 yards longer than it is wide.
30 yards longer than it is wide. So I got to somehow incorporate that into my picture. So instead of length and width, I could change that L to being 30 yards bigger than the width. So how could I write that? Yes. And then the area they're going to tell me. So normally I'd say length times width gives me the area, but in this case, I'm not going to use that. I'm going to use width and width plus 30. So let's do width times the length, which is width plus 30. And there's an equation. And if you multiply it out, it's a quadratic. And if it's a quadratic, I've showed you 4 ways to solve them. 3 mainly. One of which is graphing. Graph this side, see where they cross. Now that's kind of a pain because the 8,800, you got to get way up on the graph and it takes forever to find it. So in this case, I would actually move this over to the other side and then just find where the x-intercepts are. Those are a lot easier to find. They're easier to see on your graph. Okay? So I'm going to leave it to you at this point. I will tell you that the window's a little bit of a pain in the butt to try to make this graph work, but use x, and you use x times x plus 30 minus the 8,800 is equal to 0. You actually multiply this thing out if you want to. It might be smarter. Don't have to. Calculator can do it. Graph the thing and see where it touches. Now the tricky part about seeing where it touches is getting the window right. And you got to get it big enough because remember you got an 8,800 in your equation, so you know you're going to have some pretty sinking big numbers. So you better use big numbers on your graph, on your window. Now, do you guys know how to adjust the window? There's a button called window. And when you're in there, it'll let you decide what you want it to go from. And if you just go from -10 to +10, are you ever going to see 8,800? No, you're not. So you need to be able to adjust those to be bigger numbers. All right? I'm going to hit pause for a second. I'll answer a question. Okay, we're just taking a second here to make sure everybody knows how to do the that little second calculate menu. That'll tell me intersections and it'll tell me zeros. Right now, I don't have anything to intersect with. I couldn't even do intersection if I wanted to because you only have one equation in your calculator. What could we do, though? Zeros. So everybody go second. Calculate. It's right above trace. Can't find it? Ask your neighbor. Behind? Second calculate. In your calculator. All right. Then, once you're in there, choose 0. And what's the first question it asks you? Say it. Left bound. You want to be on the left side of one of these. Let's choose to focus on the left one here. So we need to be to the left of this one. So get your little spidery thing to the left of it. Then hit enter. And then it wants the right boundary. Get just to the right of it, which is underneath it, but that's irrelevant. We want to be to the right of it. And then when it says guess, get right on top of it and then hit enter. And what do you get? -1.8. Can anybody verify it's -1.8? You got the same thing? Okay, good. Then go to the other one and do second calculate zeros. And it'll say left boundary. You get underneath it this time because you are to the left of it when you're down there. And then to the right of it. And then you go over the top of it and you hit enter. And what do you get? 0.18. Can anybody verify that? Okay, good. Now here's the other thing I need you to know how to do. Go back to your y equals screen and type in a second equation. Leave the first one there. And type in a second equation of y equals 2. Now think about it. Where will that graph? A line like this. Go ahead and graph it. Do you see the line on your graph? Now we can do intersection. So go to second, calculate, intersection. And I can see where those two lines intersect. I can move my little spider around. And it'll say first curve. Well, you get onto either the parabola or the straight line, and you call out your first curve by hitting enter. And then you get on the other one, and you hit enter. And this third one actually matters now because it says guess. There are two spots where they intersect. There's either this one and it can tell you that, or this one and it can tell you that. If you get over this one and you hit enter, then it'll tell you that one. And what does it tell you? Negative what? 2.13. Okay, can anybody verify that? Okay, good. And then try it again. Do second, calculate intersection. Get on the first curve, get on the second curve, and then get right over the spot where they cross, and then hit enter, and it'll tell you that one, which is what? 0.46? All right. So we are solving quadratics by graphing, and there's two different ways to do it. One's called the intersection method. That's where you have two lines that are intersecting. And the other way is just finding the zeros, which is this way where you make it all into one equation and graph it and have it equal 0, and you see where it touches the x-intercepts. All right, we have covered pretty much almost everything that you need to know. We did 59, which was one of the word problems. I got it all set up for you, but now let's do number 60. Just look at number 60 real quick. I'm going to give you some hints for that one. Number 60 is about a fireman, and it's a classic ladder going up the side of a wall. Oh, it's not a fireman, it's a paint guy. John's paint crew knows from experience that its 18-foot ladder is particularly stable when the distance from the ground to the top of the ladder is 5 feet more than the distance from the building to the base of the ladder, as shown in the figure. In this position, how far up the building does the ladder reach? Now, the nice part is that they gave you the picture, and they put everything on it. But you should sketch that on your paper, just like I just did. The bottom's x, this side's x plus 5, and this is 18. That won't take you very long. All right, once you got that, what did I tell you? You always make a picture, and then what's next? You always make a equation. What equation can you make with the sides of a right triangle? A squared plus b squared equals c squared. Yes. And that means I can take these sides and put them into that equation. And this is like A, and this is like B. Actually, you can interchange them. It doesn't really matter. And then this other one has to be the C. So I'm going to say x squared plus x plus 5 squared equals 18 squared. And is that a quadratic? Because it has to have a little x to the second in it. Yes, it does. And so therefore, you can solve it like we solved all the others. I'd graph it if I were you. And when you're done, remember that your answer comes out to be a distance that makes sense in this picture. So don't you think, like if the answer came out to 50, wouldn't that be kind of messed up if the hypotenuse is 18? So it's got to be something more like, 10 or 13 or something less than 18. So when you're all done, if your answer comes out negative, that also doesn't make any sense. You can't have a negative distance from the wall. So anyway, there is some advice on setting up word problems. That advice I'm going to repeat to you many times. Draw a picture, make the formula, then take the stuff from the picture and put it into the formula. That's how you can solve word problems really well. Okay, that's enough for today.